We have all seen the images of dead malls, massive, hollowed-out ruins that used to be the center of American commerce, now sitting completely empty. The gap between these two outcomes is governed by a strict mathematical relationship between physical square footage and store diversity. I'm exploring the science of retail survival. If you want to dive into the hard data driving this research, you can find the underlying studies over at sherrysue.com. For decades, the real estate industry has constructed billion-dollar properties using a surprisingly fragile strategy. Developers allocate square footage, they choose tenants, and design layouts based almost entirely on trial, error, and gut feeling. To prevent more retail spaces from failing, researchers realized they had to abandon the traditional architectural view. Instead of treating a mall as a collection of leased concrete boxes, they began analyzing it as a living biological ecosystem. By dropping standard business school guesswork and applying the laws of evolutionary biology, we can accurately predict exactly how a retail environment will perform. Island biogeography explains how wildlife populates an isolated landmass. A mall functions similarly, a closed footprint disconnected from outside resources. Inside, stores act as competing biological species, fighting each other for the same limited resources to stay alive. Ecology gives us the power law of species and area. This rule states that the physical size of a habitat strictly dictates the maximum number of distinct species it can support. You cannot fit infinite diversity into a finite space. This scatter plot shows the natural logarithm of tenant species mapped against the total gross floor area of sample shopping malls. The data proves that retail diversity follows this biological law, plotting along a mathematical exponent of about 0.20. If a developer ignores this natural limit and tries to cram too many different types of stores into a small mall, the habitat becomes overpopulated. The stores cannot secure enough resources, forcing species extinction and business collapse. But knowing the number of species is only half the equation. We also have to know how much space each species gets. In biology, this is called niche preemption, where populations naturally divide their habitat into a strict geometric distribution. This chart tracks the floor area allocated to shops in 5 major malls. Notice how closely they track the red geometric curve. An apex species, the massive anchor tenant, claims roughly 30% of the territory, while subordinate species carve up progressively smaller fractions. The ISAR model expands this framework by adding environmental energy, the biological fuel that sustains the habitat. In a retail habitat, energy is the total household purchasing power available within a strictly defined 5-mile radius of the property. That money is the caloric intake of the ecosystem. By multiplying the physical square footage of the mall by the local economic energy surrounding it, we find the absolute maximum potential of the ecosystem. In 2022, researchers proved that balancing area, energy, and store diversity creates a specific mathematical state called a tenant mix equilibrium. Hit that exact balance, and the mall thrives. If a mall has an overmix, offering consumers too many small choices in a constrained space, individual shops can't generate enough profit to survive, dragging down the total retail rent. The inverse is also true. Create an undermix by relying on a few massive megastores without smaller supporting shops, and you fail to generate the biodiversity necessary to attract multi-purpose shoppers. Foot traffic drops, and the property's overall rental income suffers. Developers effectively become habitat managers, tasked with maintaining a specific ecological balance to preserve the mall's financial health. Upsetting this ecological balance forces the mall into a state of inefficiency, where rent yields begin to drop as the internal diversity moves further from its mathematical equilibrium. To read the full Island Species Area Energy Study and explore the exact math behind this equilibrium model, head over to sherrysue.com.